So this is a quick video to go over the construction of my Maho MH400C 1982 milling machine spindle. So this is for the vertical head. I might do another video that go over the construction of full head, but this is just a spindle. So inside, first of all, there's the grabber, the pull side grabber. I'm not really interested into this right now. This goes inside and the hydraulic cylinder screw at the top and pull on this. Let's put that on the side. Then there is the main spindle, the housing, the bearing, and the retaining ring. So it's an incredibly simple construction, which make it really hard to service. You're gonna see what I'm talking about. So to put it together, you first need to install the bottom bearing on the spindle. Then there is a groove here for this retaining ring. It goes in that groove. I didn't want to pull it out because I don't want to scratch my spindle, but that ring is going to go in that groove there. Once you have this on, you can pull the quill or the housing, whatever you want to call it, on it. Then next, you would put your top bearing. That is not complete. We'll talk about that. Then the bearing inner race, which is actually an interference fit with the spindle. And then you would clamp together everything together with the retaining ring, which just screws on. The retaining ring. So when you want to take everything apart, the retaining ring, there is a 3 locking screw. So you would unscrew the retaining ring, and then you can remove the top bearing if you want at this point. No, you cannot remove because there's the bearing race is actually press fit on the shaft. So the question is, how do you remove this? It's quite a hard challenge because you don't have a lot to grab on to. So there's this little surface here you could grab on, but you need to be able to press this spindle out of there. And you don't have a choice. It's gonna press on the bearing. So in my case, I took this apart years ago when I was young and stupid. And what I ended up doing is simply banging it on a piece of wood, and that ended up pushing the spindle out. But I would really not recommend this because this is what I end up with. So as you can see, I exploded the roller of my bearing, which was actually not that big of a deal because the reason I was taking it apart is because of this. I don't know if you can see, but this surface is completely gold up. And this is because this spindle, this machine was used in a school where they were machining wood, and there's actually no seal at all at the top of the spindle. So all the dust can get into the spindle and ruin your bearing. And this is what happened in my case. I was lucky enough at the time, so years ago, I was able to source this brand new bearing. So this is the bearing, this is the top bearing. It's a Gamut Super Precision 71-03500. So my plan is actually to regrind this surface inside. I'm not sure yet how I'm gonna do it, but that's a long-term plan. And I can do this because the bearing actually, the inner race, doesn't actually rest on that ledge or that surface there. The preload is actually established with the ring, with how much you screw the ring, and not with the geometry of the shaft. So by grinding the surface a bit, I'm going to be able to move that bearing down a bit, just clamp it a bit more, and I should be good, theoretically. We'll see. Worst case, I can remove a tiny bit of surface here to allow me to move that inner race further down. Anyway, I hope hope this helps someone. I will probably do another video where I go over the construction of the head itself and the bevel gear. We'll see.